All right, sorry, I didn't have voice for a while here. I'm going to show you guys a MongoDB example. Unfortunately, MongoDB has some pitfalls with respect to installation, but if you remember, MongoDB is a cloud-based solution here, or a cloud-hosted database. So in reality, the server managers are going to have MongoDB set up on a server for us, and we're just going to have to know how to interact with it. So instead of me wasting time going through the installation on Linux, Mac, and Windows, I just want to show you how to interact with a MongoDB. And again, we're using MongoDB kind of similar to how we've done everything this semester, and that is we're going to host it locally, or I'm going to host it locally, and just turn my computer into a pseudo server. We'll access it through localhost and the port. On Linux, it's actually fairly straightforward to download. I've tested it on a couple different distributions. Mac, it's more of a pain. You must use Brew. For my Linux users, Brew is like a package manager, like Yum or apt-get, but it's bulky. I don't want to force my Mac users to download and put Brew on your system because there's really no need. But to operate Mongo on OS X, you kind of need Brew. So I'm going to show you that process at least, because I'm going to do this on my Mac. Windows I haven't actually explored yet. It doesn't look that challenging, but again, since there's only a couple weeks left of this semester, I don't want to waste our time with technical difficulties and installation and downloading and stuff. I want to instead show you how we would interact with a MongoDB server from Python code. And if anyone really wants to use this for the project, I will work with you and I'll help you get it set up. So that is going to be a as needed basis. So if we're really interested in using MongoDB for our project, I need to know sooner than later. We'll talk about that with our first Zoom lecture coming up here. But instead, let me show you a machine learning example using MongoDB. And I'm going to do this line by line. So you guys can hopefully follow along easier versus me just putting the code out there and then just talking about it. You'll see me type it out and we'll discuss it as we go. I've got a few import statements already in here. Hopefully that's okay. You should recognize that train test split one from last semester. We're importing data sets. We're going to use the Iris data set here instead of a custom one. But for the next lab, I'm going to force you guys to choose a different data set and do a similar process like this. I am exploring a Docker solution for Mongo. However, that also has some hiccups depending on the distribution you have, because Linux you have to usually use sudo to launch Docker. So therefore your Python code inherently doesn't have the proper permissions to access that container. It's just a silly little thing we'd have to work around, but again, I think it would waste too much time. So let's just go through this example. We'll discuss it further in our Zoom lecture, and if we want to learn more, I will certainly post and publish more. But here, we're gonna do an SVM example, since I know we've all done this last semester. We've all seen the Iris data set. So let's just go with that. And you see that top one, the top import statement is PyMongo. That's how we're gonna interact with our database from Python. And there's obviously several other languages that you can use to interact with Mongo, but it's all just the same. We're a Python class, so we're doing it in Python. So here we're gonna do Iris dataset. So it's pretty straightforward to get it, since we're imported data sets from Python. Those are all built in on your system. Forgive me ahead of time. I'm sure there's going to be some typos here, but again, I thought it would be more beneficial for me to just go through this line by line so you can see it. All right, so I hope you all know what I just did on this line from last semester. The, this first lab that I'm going to make you guys do is going to revisit some of this stuff, and we're going to maybe containerize this. It all depends on what we can do with Docker, but this coming lab for this first week back is going to be machine learning based. So get ready. So now we are going to define a training and a testing set using our friend train test split. And surely a question I will ask you in your lab assignment is what the default ratios are, which is why I'm not going to type anything right there because I'm just going to use the default. Obviously, you could specify more arguments. There's plenty of them. We're going to do an SVM classifier. So let's just do my SVM class equals SVM dot SVM. So if you remember, now we are instantiating this model. Hopefully that is familiar from last semester as well. And then we're going to train this thing. We're using the fit attribute, and we're going to fit it to the training data. Okay, so let's just run through this, make sure it's all good. Beautiful. Okay, so we actually trained a model. We got some stuff out there. Beautiful. We are cooking. Obviously, we've done nothing with MongoDB. So what do we want to use MongoDB for? There's two reasons. One, for data storage. It works great. We can have CSV files floating around the internet, sure, but it makes a whole lot more sense to store this in a cloud form or cloud database like Mongo, and then be able to retrieve it. The nice thing is we can all use APIs to retrieve this data from a MongoDB. So these next two functions or definitions that I'm going to write for you are doing exactly that. They're going to save our model to a DB, and then we're going to retrieve that model from a DB. In class, oh man, this was like 2 weeks ago already, or 3 weeks ago. I showed you basically how we would start a Mongo database and put some stuff in it, or create a database and put some stuff in it. And this is really the same. I mean, if we wanted to put a bunch of like the iris data set, now that's actually a good idea. I might show you also how to put the iris data set into a MongoDB and call it. That might make some sense. But for now, I'm just going to show you how to create a model and then save that model to the database, call the model back from the database, and make a prediction. So again, if you bear with me, I'm going to do this line by line. So, well, first let's say what we're going to do. We're going to create a definition that, sure, we could use this with an API to save our model to Mongo. All right, so first thing, def, save to Mongo. That sounds about as good as we can do. We're going to need some things in here. So we're going to need a model, obviously, to save. We're going to need a client. We're going to need a DB. We're going to need a database connection. And we're going to want a model name here too. So I'll leave it up to you to determine how many arguments our current definition needs. It should be pretty obvious, but we're using something we haven't seen before here in this pickled model. It's allowing our model to be in a form such that we can just dump it. I will explain that further in class. or there's plenty of documentation out there on it as well. But all right, so my client is obviously somewhat, this is important now. So this is actually how we're going to connect to our DB. So here we're using our PyMongo that we imported, our Mongo client, and client. This should all make more sense to you when we actually call this. So just bear with me here for a second here. So my let's just call it my DB equals. And I hope that this is going to be bug free, but we're kind of going off here. So my connection is going to be, and there are similar tutorials out there like this. I'm not reinventing, or I'm not creating from scratch here. So there's plenty of documentation out if this is not clear. All right, so now we want to do my DB connection. Okay, so we've obviously taken two or several of the arguments now here, model, client, DB, and DB connection from the save to Mongo. So should be a pretty good indicator of what is required in this definition. Let's create some info. So I forget if I discussed insert one and insert many. I thought I did, but maybe I didn't. But so you can insert many, which would be obviously many lines, or you can insert one line. But we're using insert one clearly here. The fancy curly brackets should mean something to you guys, hopefully. I just want to make sure I am spelling everything correctly, and I can't be, because, okay, let's just go fix it here, because that's not right. There we go. And again, I want you guys to think about what these different things mean that I'm typing out, which is why I'm typing them out in glory detail. All right, make sure we're closing that. Beautiful. All right, so some useful thing that we might want to do at the end of our definition here, let's print something so we know we did something in our definition. This is pretty good practice, I would say. Okay, so let's see. Yeah, we did something right. Maybe. All right. And we're going to do some details here so we can return it. Again, curly brackets should mean something very specific to you guys. I hope I don't have to spell that out. But ask if you don't remember. Now, if you see up above, we're calling info and making it equal something. So we should have an idea of where these guys are coming from here. One thing I might have you guys do as well is come up with a better way to showcase the time. I could be wrong, but I'm pretty sure this is going to show us the time in like seconds. It'd be pretty nice to get a date there, I think, or it would be nicer to have a date. All right, so we're just going to return the details at this. Let me just make sure like nothing crazy is happening. That looks right to me. So this is the function that you could use to save a model to um, uh, a MongoDB. Um, so the next step was obviously to fetch that model. So let me just, all right, I guess one quick thing. So you've never seen this pickled model, pickle.dumps. Just know that it's a way to serialize and deserialize models, which is what we're going to have to do when we want to put them or save them to a database like Mongo. I think this is a good Piazza discussion actually on why that would be useful. So just believe me for now. Yeah, it's a pretty nice function. Now we're going to create a definition to load, say load from Mongo. All right, so you could guess. We're going to need a model name. Obviously, we're going to need a client, we're going to need a DB, and we're going to need a DB connection. Checking for, all right. So, favorite word, one of the favorite words from this class. We're going to need to create some JSON data, empty curly brackets, again, should mean something to you guys. Now things should start coming together. So the client is the actual location of the database. So for us, it's going to be on our local host. However, if this was in a real server or something like that, client would be defined as something slightly different. I'm getting a little bit ahead of myself, but I just want to point that out that it's like a real address somewhere. Just, all right. So and then the DB here is how we're gonna name our database. Yeah, where am I? So we need this again. So remember that this database is a series of collections. Don't expect you guys to ever have to reproduce that in this class anyways, but it's useful with respect to thinking about SQL and NoSQL and how data structures are stored. And here we're going to strictly call them collections, but again, that's not that critical. It's just a little caveat. All right, so now we are actually looking in the MongoDB using a find, and we're going to look for it by name. Which should make a little bit of sense. Now for the fun. So we're going to have to do a loop. And I will allow you guys to post about this for participation points why we must loop through this, but it should now make total sense why we had an empty structure of JSON data above, and what those curly brackets actually mean to us. Okay, this should be right. This looks right. Except for I'm sure there's a typo somewhere that we'll have to shake out. All right, so you should see that like when we saved it, we have to serialize. Yes, we have to serialize here using pickle. And when we're loading it, you can see that we're basically unpacking it and putting it back together in Python world, which is why we're returning this. Okay, let me just do this, make sure there's nothing crazy. All right, so now for the fun. So let's do some things. Well, yeah, details is fine. All right, so we want to save to Mongo. So now we're going to call our function. And remember, we created a model already. So what was our model called? Good question. What did I call that model? My SVM. God, way too long. So my SVM classification. Our client here. What did I tell you it was? It's an actual location. So this is how we are going to specify that. This port is the default Mongo port on localhost. That's it right in their documentation. So DB, we're going to call it, let's see, my SVM DB. That sound fair? Sounds perfect to me. It's just, yeah, so I'm going to keep scrolling over here. All right, so now we have a DB connection. This is also part of the naming scheme. You remember in class we named and then named the inside classification. What? I don't know. Class. Sure. That sounds better. Model name. My SVM. Okay. Let's cross our fingers and see if this will work. Oh, look. So, great. That happened fast. And let me just drag something over. A common error that will inevitably happen if you're actually using this is that you'll get an error and it will say, hey, the connection was refused. So let's see here. I had to start the service. So the service might not be running, but now you can see that I have started the service and it's running. Okay, so we've just saved something. This is the identification that is given with Mongo, and see, we did right here. So inserted ID, since we inserted one, this is what it's printing. So we did something right, hopefully. Beautiful. Now that we have saved a model, and we've actually saved the model we trained above to the database. Let's try to go fetch that model. So now, let's call it, I guess, we can call it the same thing. Well, let's not. Let's call it my test and see, to prove to us that we got something different. This should work the same. All right, so load from Mongo. Now we need a model name, but the beauty of this now is we can use this details that we created. Yes. Okay. So we still have to specify these things. So MongoDB. Down here, so DB. What did we call this thing? My what? Hopefully that was right. Okay. Let me just make sure. So, oh no, this is not. So obviously we need to keep it the same. So, all right. All right. So now let's walk back through this now and make sure we got this right. Okay, this looks right. All right. Yep. So we are loading it. Loading this database, this collection inside the database, which should all match up with this. So let's give that a whirl. And I did something wrong. Oh, I can't type. So look at that. Told you there'd be a typo. Hopefully that's it. All right. So it's very uneventful since we didn't print anything. We could have obviously printed something here. Let's go ahead and do that. I think we can. Let's just print a statement. So loaded from DB, and let's make sure. So this should hopefully like us. Okay, so now it at least ran it. We loaded this model from the DB. We know we can actually test this now. So we loaded, or we saved my SVM class, the model we just trained above, right here, this class. We save that to the database right here. Now we have just loaded it from the database and called it my test. So how would we know if this worked? We could do my test dot predict, and this is looking good because, well, it came up with an attribute, so it must know it's a class. So let's go ahead and print. Let's print this. What do we want to predict? Obviously, we need to do X tests. right? That should make sense. A lot last semester, cross our fingers. Holy smokes. Okay, so we just did a classification prediction. I'm not going to go through on how good or bad this was, but we did something. Uh, so again, we did an SVM classification on the Irish dataset. We trained this model, called it SVM class. Okay. We then created a function or definition that saved it to a Mongo database. And then we also created a function that loaded it from the database. So now that these two functions exist, all we have to do is call them like so. So this saved this model to a MongoDB that is hosted locally here, named in this database with this, sorry, I keep wanting to say classification, but collection, okay? This is the collection name, this is the database name. And the model name was mySVM here. Then when we loaded it like so. And since we had details up here, we were able to do this like so, like model name, okay? So details model name is actually the model name we named it, right? That should make some sense, hopefully. Loaded it from the MongoDB and then actually made a prediction with that after we renamed it. Okay, cool. Let's post questions about this if we have any.